Welcome to the error paradox, where we explore why failure is essential for innovation, yet most systems punish it mercilessly. This paradox reveals a fundamental truth. The path to breakthrough innovation is paved with mistakes, failures, and errors that contain vital information. Let's start by understanding what makes this a paradox in the first place. Innovation fundamentally requires experimentation, taking risks, and trying new approaches that might fail. Yet, paradoxically, most organizations, educational systems, and social structures systematically punish failure and reward only success. Here's the paradox visualized. To reach success, we must travel through failure, yet failure is marked with a big red X and punished. This raises an important question. Why do we systematically punish the very thing that innovation requires to flourish? Let's examine the mathematical and scientific basis for why error is actually information. Information theory tells us that the information content of an event E equals negative log base 2 of its probability. This means rare, unexpected events like errors carry far more information than common, expected outcomes. For example, if an error has only a 1% probability, it carries about 6.64 bits of information. But if something succeeds 99% of the time, it carries only 0.01 bits of information. The error is 664 times more informative. This graph shows how information content explodes as probability decreases. Rare errors at the left carry massive information compared to common successes. Bayesian statistics provides another powerful lens for understanding how we learn from errors. Bayes' theorem shows how we update beliefs. The probability of hypothesis H given error E equals P of E given H times prior P of H divided by P of E. When unexpected errors occur, they force us to dramatically update our mental models and hypotheses about how the world works. Consider drug development. About 90% of candidate drugs fail in clinical trials. For every 10 drug candidates, about 9 fail. But each failure teaches pharmaceutical companies crucial information about biology, chemistry, and human physiology. The learning rate is proportional to error magnitude. Bigger surprises produce bigger updates to our knowledge. The error paradox connects directly to the fundamental exploration-exploitation trade-off in decision theory. The upper confidence-bound formula shows optimal exploration. Value of action A equals estimated reward Q of A plus C times the square root of log T divided by number of times we tried action A. Exploration fundamentally means trying unproven options and accepting that many attempts will result in errors and failures. Exploitation means sticking with known good options that avoid errors but also avoid discovering anything better. Exploration generates many errors shown in red, while exploitation generates few. But without exploration, we never discover breakthrough innovations. This raises a crucial question. What is the optimal error rate for maximizing innovation and discovery? Research suggests there is indeed an optimal error rate for learning and innovation. Studies in machine learning and education suggest the optimal error rate is approximately 15%. This 15% error rate maximizes information gain per attempt, while still maintaining enough successes to build on. If the error rate is too low, say 1%, we are not exploring enough, and our learning stagnates. If the error rate is too high, say 50%, the system becomes unstable, resources are wasted, and people become demoralized. This curve shows learning efficiency peaks around 15% error rate, then declines as errors become too frequent. Let's look at a concrete historical example of embracing errors. Thomas Edison and the light bulb. Thomas Edison famously tested over 3,000 different materials as potential filaments for the incandescent light bulb. His success rate was 1 divided by 3,000, which equals about 0.033%. That is a 99.967% failure rate. Edison famously said, "I have not failed. I have just found 10,000 ways that will not work." Each red circle represents hundreds of failed experiments. The single yellow success came only after systematically eliminating what did not work. Each failure eliminated wrong paths and progressively narrowed the search space, making the eventual success more likely. What happens when organizations and systems punish errors instead of learning from them? When errors are punished, innovation velocity decreases dramatically as people become risk-averse and stick to proven approaches. Innovation rate is proportional to risk tolerance. Punish errors and risk tolerance collapses. Many corporations engage in innovation theater, where they claim to encourage innovation but systematically punish any failures. The pattern is predictable. Innovation rhetoric at the top, but risk aversion in the middle leads to stagnation at the bottom. The hidden costs equal all the opportunities that are never discovered because no one dares to make the errors necessary to find them. How can we design systems that embrace productive failure while avoiding catastrophic errors? Principle 1. Separate learning errors made during exploration from execution errors made during routine operations. Principle 2. Make errors cheap and reversible whenever possible so the cost of learning stays low. Principle 3. Extract maximum information from each error through systematic analysis and documentation. Create rapid feedback loops where trying leads to learning, which informs the next attempt, creating an accelerating cycle of improvement. How do the most successful innovators think differently about failure compared to the average person? Resolving the error paradox requires a fundamental shift in how we think about failure and success. We must shift from the binary thinking of success, good, failure, bad, to a more nuanced view, information-rich versus information-poor, where surprising failures are information-rich. The value of an experiment equals information gained minus the cost. Cheap errors that teach a lot have positive value even when they fail. The old binary mindset sees only success or failure. The new spectrum mindset sees gradations of information value across all outcomes. The essential reframe is this: we are not failing, we are systematically learning what does not work to find what does. Let's quantify the paradox with a concrete mathematical model. The probability of innovation equals 1 minus the quantity 1 minus p raised to the power n, where p is single attempt success rate and n is number of attempts. If each attempt has only 1% chance of success, and we try just 10 times due to fear of failure, then probability of innovation is 1 minus 0.99 to the 10th power, which is only about 9.6%. But if we embrace errors and failure, trying 500 times instead, then probability of innovation becomes 1 minus 0.99 to the 500th power, which is 99.3%. We are almost guaranteed to innovate. This exponential curve shows how probability of success grows with attempts. Fear of failure stops us at 10%, but embracing errors gets us to 99%. The key insight: as number of attempts increases dramatically, probability of eventual success approaches certainty. Nature itself demonstrates the power of errors through biological evolution. Evolution is fundamentally an error-driven process. Random mutations are copying errors in DNA. The mutation rate in humans is about 10 to the negative 9 per base pair per generation. The vast majority of mutations are either neutral or harmful to the organism. But the rare beneficial mutations, perhaps 1 in 1,000, drive adaptation and evolutionary innovation. Evolution generates variation through errors. Most mutations shown in red are harmful, but the rare beneficial mutation in green drives adaptation. Evolutionary success equals the sum of all beneficial errors accumulated over time. Without copying errors, without mutations, evolution would be impossible, and life would still be single-celled organisms. Let's explore practical ways to apply error-positive thinking in different domains. In education, replace punitive grading with mastery-based learning, where errors are expected steps toward understanding. In business, implement blameless postmortems that analyze failures to extract lessons without punishing individuals. In science, publish negative results so other researchers learn what does not work and avoid duplicating failed experiments. Error-positive practices can transform education, business, science, and technology by changing how we respond to failure. In technology, adopt fail-fast methodologies where rapid prototyping and quick iteration replace lengthy planning cycles. There is deeper mathematics governing how errors and innovation relate. Entropy h of x equals negative sum of p of xi times log base 2 of p of xi. This measures uncertainty in information. Systems with higher entropy explore more diverse possibilities, make more errors, but discover more innovations. Innovation is proportional to entropy times selection pressure. High diversity with strong selection generates breakthroughs. A high entropy system shown here with scattered yellow dots explores many possibilities simultaneously. A low entropy system shown here with clustered dots sticks to known paths and rarely discovers anything new. Can we predict in advance which errors will turn out to be valuable for learning and innovation? Here is the profound challenge. We cannot predict which errors will be valuable beforehand. The value of error I is fundamentally unknown until after we run the experiment and analyze the results. This is why we must tolerate many errors to maximize learning and innovation. In conclusion, the error paradox highlights the critical role of errors in driving innovation and learning. By embracing productive failure and learning from errors, we can accelerate innovation and achieve greater success. The key is to balance exploration and exploitation, tolerating errors while minimizing their cost and maximizing their informational value. And remember, errors are not failures, but stepping stones to success, providing valuable information that guides us toward our goals.